Today's lesson is going to focus on trig word problems. We're going to be looking at a couple of word problems that require us to set up triangles and to solve using the trig ratios that we've been working on. Before we can get into those word problems, there's a few new key terms that we have to introduce. Once we've gone over those key terms, we're going to work through a few problems together, demonstrating how to set up the question, how to draw out the triangle, how to label everything, and then we're going to work through solving using the trig ratios. What I suggest is that for each of the slides, you pause the video, copy down the information, and then follow along with the lesson. So to start, we're going to introduce our new terms. The two key terms that we need to address today are the angle of elevation and the angle of depression. These are similar ideas that have to do with constructing right triangles and knowing where to put the angle. So, let's take a look. When a person looks at something above his or her location, the angle between the line of sight and the horizontal is called the angle of elevation. In this case, the line of sight is elevated above the horizontal. We can see here that the line of sight is your vision constructing the hypotenuse of a right triangle, and that the horizontal is the base of the right triangle. We end up with an angle of elevation because you're looking from the ground up. On the other hand, when a person looks at something below his or her location, the angle between the line of sight and the horizontal is called the angle of depression. In this case, the line of sight is depressed below the horizontal. So we again see that our line of sight is used to construct the hypotenuse of our right triangle, and that the horizontal is going to be used to construct the base of the triangle. In this case, we are looking down, so our angle is one of depression. Since the vertical and horizontal directions are perpendicular, the elements of problems dealing with the relationship between lines of sight and the horizontal lead naturally to right triangles. So what we're saying here, when we talk about this perpendicular, we're talking about the fact that you would be dealing with a vertical line representing the height of something, and the horizontal, the base of the triangle. So that could be either for an angle of elevation heading up, or we could see for an angle of depression looking down. Both cases work, and both cases end up constructing right triangles. So regardless of what you're dealing with, you have to be able to deconstruct the problem. Whenever we see that phrase, angle of elevation, we know that we are looking from a horizontal and going up. So that helps you out with identifying how the angle should be constructed. If you're dealing with an angle of depression, then we know you have your horizontal and that you're looking down. So that will allow you to construct the location of your angle again. Typically, we would then build a height of some kind represented by a right angle and complete our right triangle. We're now going to take a look at a few examples on how we would deconstruct the question, label our triangle, and then solve. We see in our first example, a person stands at the window of a building so that his eyes are 12.6 meters above the level ground. An object is 58.5 meters away from the building on a line directly beneath the person. Determine the angle of depression of the person's line of sight to the object on the ground. So we have a lot of information here. Let's start out with what we're told about the person's eyes. We're told that this person's eyes are 12.6 meters above the level ground. That is our height for this triangle. We're told that an object is 58 meters away from the building. That is the base of our triangle. Next, we are asked to determine the angle of depression, which would be this angle right here. Now, the important thing with angles of depression are that they often construct the angle outside of the triangle. Luckily for us, there's an angle inside the triangle that's going to be the exact same measurement as the angle of depression. So, if you're dealing with an angle of depression question, set up your problem and then use the angle inside the triangle as your reference angle. Based on this, we have our opposite side and we have our adjacent side. Opposite and adjacent are a tangent ratio, so that means this question will be solved using tan. We know that tan is equal to opposite over adjacent. We're looking for an unknown angle, so we have tan of, and this symbol is called theta. Our opposite side is 12.6 meters. Our adjacent side is 58.5 meters. So this means angle theta is found by taking the inverse tan of 12.6 over 58.5. We'll put that into our calculator and find that angle theta is about 12 degrees. So this means that our person is going to be looking down 12 degrees from the horizontal, as seen right here in our picture. So you would be looking out straight and then down 12 degrees. To finish this, we need to write a statement for all word problems. So we can say, therefore, the angle of depression is 12 degrees. And that will finish off our question. So for all of these word problems, it's very important that we remember this last step here. We have to include that statement in order to complete our work. In our second example, we are also looking for the angle in our problem. So let's look at this word problem and then we're going to try to solve it. So this example says, calculate the angle of elevation of the line of sight of a person whose eye is 1.7 meters above the ground. This is looking at the top of a tree, which is 27.5 meters away on level ground, and 18.6 meters high. So there's quite a bit going on here. Let's start out with what we're told to do. The question says to calculate the angle of elevation. Well, there's our angle right there. The scenario we're looking at shows us that the person is 1.7 meters above the ground. This just means that they are 1.7 meters tall. When you're looking at something, you're not looking at it from the ground. You're looking at it from how tall you stand. So that's why we have that 1.7 meters. We're looking at a tree. So for context, we've got a tree over here. And that tree stands a total of 18.6 meters tall. Okay? And we're told that that tree is 27.5 meters away, so there's the base of our triangle. Now you'll notice there's another measurement over here, and that's because we have to take 1.7 meters away from the 18.6 meters, meaning the height of our triangle will actually be 16.9 meters. And that's just because the person would already be standing 1.7 meters tall, so we have to start the triangle where their eyes are, not down where their feet are. Alright, so now that we've broken down the question, let's gain an understanding here. We have our angle of elevation as our reference angle, and across the triangle we have a height of 16.9 meters. That means that 16.9 meters is our opposite. At the base of the triangle, we have 27.5 meters touching the angle of elevation and the right angle. That means this is our adjacent. Alright, so we've worked with these before. Opposite and adjacent, again, is going to be a tangent question. So, tan is opposite over adjacent, and we're going to fill in the information that we know. We're looking for an angle, so we have tan of theta is equal to our opposite of 16.9 meters over our adjacent of 27.5 meters. So to find angle theta, we are going to use the inverse tan for 16.9 over 27.5. When we work this out in our calculator, we should be finding angle theta is going to be equal to 32 degrees. And now, just to finish it off, we need to remember that each of these word problems needs a therefore statement. So, therefore, the angle of elevation is 32 degrees. So we've looked at two examples that had us deal with our angle of elevation or our angle of depression. Now we're going to look at one final example that will give us our angle and make us solve for an unknown side. Our last example says a flagpole needs to be secured to the ground with a wire. The flagpole stands 14 meters tall. The wire is anchored to the ground and forms an angle of elevation of 28 degrees. How long must the wire be? So like before, we're going to start by identifying the information we're given. We're told we have a flagpole that is 14 meters tall. We know that the anchor of the wire is going to create an angle of elevation of 28 degrees, and we are asked, how long must the wire be? So we need to build our triangle. We'll start by making our flagpole, which we know is 14 meters. So we'll drop that right there, and we will label it as 14 meters. We don't know how long the wire is, but we do know that it's going to create an angle of elevation. So, in order to make an angle of elevation, that would mean that it has to go from the ground up. So, we'll draw in our wire from the ground all the way to the top of the pole. This is our flagpole's wire, and we don't know how long it is, so we're going to represent it with an X. We know we're making a right angle here, and we're told that we have an angle of elevation of 28 degrees. We know it's an angle of elevation from the question here, and that means it has to go from the ground up to the wire. We'll do our labeling. From our angle of elevation, we go across to the flagpole, so that's our opposite. And from the right angle to the wire means this is our hypotenuse. So the trig ratio that uses opposite and hypotenuse is sine. We will say that sine is equal to opposite over hypotenuse. We'll fill in our information. The sine of 28 degrees is going to be found from 14 meters over our unknown. Based on what we reviewed yesterday, we'll switch these two and isolate for x. So x will be equal to 14 divided by sine 28. And now we can punch that in and solve, giving us a length of 29.8 meters. And that would make sense because this is our hypotenuse, and the hypotenuse has to be longer than the other sides of the triangle. So, therefore, the wire must be 29.8 meters long. And there we go. So, I have attached a worksheet that has some problems for you to solve using trig ratios, and you'll have all of today and tomorrow to complete that, with our final lesson for the week happening on Thursday. So, if anyone has any questions, just shoot me an email. Otherwise, see you all here on Thursday. Bye for now.